What if your game needs to check if an enemy is nearby, or if the player has enough health to survive a hit? How do we check conditions like these in code? That's where Boolean values and expressions come in. We have covered this briefly in the previous video, but we will take a look at it again in this video so that we get a much more clearer idea of what it is. A Boolean or a bool is a data type that can have only two values. True, meaning yes, it is happening, and false, meaning no, it is not happening. In C#, we can write a boolean like this. We write public bool is game over equals false. Public bool has key equals true. And this is used to store whether a condition has happened or not. And the thing about that is we can create a variable, but we can store the value while we are in the game. For example, inside the update function or something. And these values are everywhere in games. Is the door locked? True or false? Is the player alive? True or false? Do you get it? But how do we check for conditions in game? We do that with Boolean expressions. And we need to use relational operators. We've looked at this in the previous video. We'll look at it again. There are 6 relational operators. They are pretty straightforward. Equals is used to check equality. Not equals is used to check inequality or not equal to. Then we have greater than, less than, greater than or equals, and less than or equals. These are the relational operators, and we use them to perform a relational operation. For example, we can have two numbers and then check if one is greater than the other, or we can check if they are equal to another. Maybe we could have two game objects, and hey, we could check if they are the same object by using the equal to, right? There's a lot of things that you can do. Let's look at an example in code. Okay, let's get into the habit of reading code as well. We have public int health equals 50. In start, we created a bool called isAlive equals health greater than 0. Equals is the assignment operator. Firstly, it will calculate whatever is there on the right hand side of the assignment operator. It will perform the operation health greater than 0. Health by default is 50. 50 is greater than 0, meaning it will return true. So it is sort of the same as writing bool is alive equals true. But this value of true, which is on the right hand side, is actually an expression. This value of health could change at any moment. And we print or debug.log is alive. Let's see how it works in the game. In our test object, currently health is 50. If we play the game, it prints true. Now if I go and set this to -10, it prints false, which is good. So this is how we perform conditions. In this example, we have a public integer boss max health equals 120. Another public integer current health equals 30. At start, we have a boolean called isEnraged equals current health less than boss max health multiplied by 0.4f. This is a lot more complicated. Also, we are printing whether the boss is enraged, which is straightforward. Now, what is this right hand side of this expression? Well, multiplication happens first. Okay, this is an arithmetic operation, and based on board mass, division happens first, multiplication happens after division. So for clarity, I've added parentheses here. Firstly, it will check boss max health multiplied by 0.4, meaning it's 40% of the boss max health. So it's going to be 48. Okay, so we'll check if current health is less than 48. That is this expression. 30 is less than 48. Therefore, this should give out true. And there we go, boss is enraged. But sometimes we need multiple conditions. Therefore, we need to use logical operators. There are 3 different types of logical operators. And, which is 2 ampersand symbols. Logical OR, which is two vertical bars, and logical not, which is an exclamation mark, and simply means both conditions on the left and right should be true, and only then the whole thing would be true. In or, at least one of those conditions that it's checking should be true, then the entire thing will be true. And not simply reverses a true or false value. Let's look at some examples. We have a public bool has key equals true, public bool door unlocked equals false. We have a boolean can enter equals has key and door unlocked, meaning the player can only enter if they have the key and if the door is unlocked. And we just printing can enter. So this is how you make rules in your game. Okay, now the player can only enter when they have the key and the door is unlocked, which is great. If we hit play, it is false because door unlocked is false by default. If I set this to true and then play again, player can enter the door. Let's make it a little bit more difficult. We have an integer coins equals 20. A boolean has coupon equals true. We are evaluating a boolean can by equals coins less than or equals 30 or has coupon. Because we're using or, if any of these expressions or booleans on the left hand side or on the right hand side of this operator is true, then the entire thing is true. Coins has the default value 20. So the right hand side 20 is not greater than or equals to 30. So this side will be false. But has coupon is true. And because we're using an or, can by should be true. If this was an and instead, then if this is false, automatically it's not going to even bother checking the second condition. Because it is false, then by can by will automatically be false. Okay, if we play the game, it's going to say true because has coupon is true. If I uncheck it, meaning both conditions will now be false, can by becomes false, which is great. So what have we achieved here? Now we can write conditions to make decisions in our game. In the next video, we'll use these Boolean expressions inside if-else statements to utilize their full potential. I'll see you in the next one.